just want to make one announcement for those of you who are online. Could you please write your name and affiliation in the chat? And I'll pass around a sign-up sheet for the people who are here physically. Thank you, Matt.
Thank you. Pull this chair up because my back is it. Hi, I'm Matt Donovan. I'm with the Oak Ridge National Lab Distributed Active Archive Center for Biogeochemical Dynamics, or just say ORNL DAAC. I'm here to just talk about data access and archival for Delta X. I'll be joined by my colleague Yaxing. He's our lead scientist. He'll be talking about Earth Data Cloud towards the end of the presentation. So the DAACs are part of the EOSDIS system. It's the Earth Observing System Data and Information System. Includes 12 discipline-oriented DAACs. They handle different things like ocean biology, land processes, physical oceanography. We do biogeochemical dynamics, ecological data. We support the terrestrial ecology program. Our specialty is field and airborne data, and the confluence of those two. We do other things, so that makes us a natural archive for the Delta X project. We are the DAAC of record for Delta X. That means we are the final resting place for Delta X data. So here at the DAAC, we have over 1,790 data sets, over 9 science themes, like Arctic ecosystems, fire, vegetation, soils. We have over 30,000 users per year, over 36 missions projects. This is just a snapshot of some of the projects. You see Delta X there. JEDI is pretty timely as well. Shift and Above, many people probably have worked on Above as well. We have a wide variety here at the DAAC. So Inge's process is pretty simple. With Delta X, it was very helpful. We started our communication at the outset of the mission, pretty close to the outset, and created plans for a smooth archival process, including data formats and types, and what the mission expectations of us were. So that went very smoothly. And so once we get the data, we put it through quality assurance. We create documentation. We actually have a very thorough guide document that goes with all of the data sets. We produce that with input from the data providers. It goes through many hands. So if, for instance, I miss quality assuring something, one of my colleagues will catch my mistake. And then towards the end, the data provider gets a final review before the data is released as final. So for ORNL DAAC, we handle preprint data sets. So we have a special workflow. It's for provisional data. We produce a landing page, what we call skinny documentation, which is basically a guide document that doesn't have a lot of data, but has some of the most major data points. We produce a DOI and a citation. What we don't do right now, if we know the data will be superseded within a few weeks, a month or so, we would rather wait on that. At the moment, might be a little bit too provisional, but we are always asking people, what does provisional mean to you? And what is that line? And we are happy to have those discussions about what's too provisional and not too provisional. We also handle updates and versions. We do minor version number changes. That's just for appends. If we're just appending data to an existing data set, we will make some minor data changes. And by minor, I know we've had for Delta X, we received some CSVs that might have been produced in Excel, and maybe the date in there changed to a number code. We'll go in there and change something like that, but nothing too major. The DOI and the citation remain the same, and we've had 16 Delta X datasets that have had these minor version changes. Major change is due to update in data values themselves, or a change in the algorithm that produces the values. So that will get a major version change from version 1 to version 2, let's say. The DOI and the citation changes. And the older data set is superseded. The older versions are never deleted, though. We can make them available upon request. The landing page for the older versions also stay, even though you do not have access to the files immediately, but we can provide those if requested. So we've also had 16 Delta X datasets that have had new versions, and I think we're up to version 4 for a couple of them. And sort of with the provisional conversation, if there are gray areas between minor and major changes, so if in doubt, we'll have a conversation. I've put a screenshot here of what it looks like at the bottom of the dataset landing page to show version history. And so those links there will take you to the landing page for the old version, but without files. So this was born out of a request from Mark, the last science team meeting, wanting to know where the downloads were coming from. The best we could do were countries for privacy purposes. So there's a pretty wide range, a bunch of countries between 1 and 10 downloads. And then that last category is between 201 and 2,400 downloads. Includes the United States and Vietnam. And so I was a bit surprised with Vietnam. And so I went in and I looked, and there's a wide variety of data sets that were downloaded. But I will say this is the country of origin here was self-reported. So it's not like from the IP address or stuff like that. So here are some trends for downloads for Delta X, starting way back with pre-Delta X. The first pre-Delta X dataset was archived in August of 2020. And then the first spring campaign mission came on, was archived in June of 2021. And interestingly, just a couple months ago, the main campaign mission downloads became greater than pre-Delta X. So we've got over 6,000 total individual downloads. Those are not files, by the way. That's just the download requests. So search for data at the ORNL DAAC. It's pretty simple for Delta X. You can put in Delta at the search bar at the top of our landing at the homepage for the ORNL DAAC, and it brings up a whole bunch of Delta X data sets. There might be others that will crop up in there as well. You can also search by accessing our Get Data link that's at the top of our homepage, and that brings you to a list of missions, and Delta X is in there. And there are currently 45 pre-Delta X and Delta X data sets that we have archived, and some more on the way that will make it on this page. I've circled a link that we have up. It's publications citing Delta X. So we have somebody on staff that comes through citations and updates things every so often. And she has looked at the Delta X mission page and made sure that those publications are on our page as well. And so if you get to that landing page here for publications, you'll see a list. I think there are 30 right now that we have. And it'll have the citation and the data set that was cited. And if there's more than one data set that's cited, we'll just put delta X or pre-delta X there. So you click on that link and you'll get to the landing page for the data set. And in that top box, there'll also be a citations link. If you click on that, for this particular data set, there were 5 citations, and it gets its own landing page just for those citations. So to access data, you'll need an Earth Data login. You just click on the sign in, which is at the top of most of our pages at web pages at the ORNL DAAC. It's free, and you just sign up, and you'll be ready to go to access our data. This is an example of a landing page, dataset landing page. You've got a couple elements there. You can download the entire dataset. You can access our user guide. That is the user guide to the right. That is not the entire user guide. It gets much more in detail than that. That's just the top of the user guide. You've got some keywords. You've got the citation. And then you have where you can access the data files towards the bottom. You can click on a data file and just download it by itself. There are many ways to filter. You can do a custom filter. You can filter by the date, the end date or start date, or the where it falls, the spatial extent. You can also access our data sets for Earth Data Search, NASA's Earth Data Search. All of the Delta X data sets are in Earth Data Cloud, and my colleague Yaxing will be talking more about Earth Data Cloud. So if you go to the website for earthdata.nasa.gov or search.earthdata.nasa.gov, again, the easiest way, you can just type in Delta X at the top. There is a drop-down list for projects, and Delta X is there, and you click on that, or you put the check box there, and it'll pull up, and there are all 45 of pre-Delta X and Delta X data sets in Earth Data Search. I also circled available in Earth Data Cloud. I did not have that checked just on this box, but if you check that, you'll get also all 45 Delta X data sets. This is a good way to keep up to date with Delta X data sets. You can create a subscription for your search. This could be for any search. So Earth Data Search has data from all of the DAACs. So it's a good clearinghouse for data from all the DAACs. So you can do some pretty interesting searches. And if you get your search just right, you can create a subscription. So you click there at the bottom, subscriptions, right there. And you'll pull up this page, and you name your subscription, and you create it, and you will get an email whenever there is a new or updated Delta X data set or Earth Data Search, anything that you want, you can create a subscription. And so this is the email that you would get. I have a subscription to Delta X emails. Some minor updates, you'll get an email about major updates. The preprints are not on Earth Data Search, so you will not get those updates here. But so the emails right now are not terribly descriptive, but you've got the links there. You click on the links, and it'll take you right to the landing page for the data set in Earth Data Search. There's about a 1-week lag time between publishing on ORNL DAAC site and it being pushed to Earth Data Search. So right now I want to hand off to my colleague Yaxing, our lead scientist, and he's going to talk more about Earth Data Cloud.
Thank you very much, Matt. Hope you can hear me okay.
We can hear you here.
Okay, great. Thanks. Thank you, Matt, and thank you everyone. This is Yaxing Wei. I'm the lead scientist of the ORNL DAAC. Apologize that I'm not able to attend the meeting in person. So here I'm going to present a few slides about Earth State Cloud. As Matt mentioned previously, an important effort recently going on across the entire NASA EUS disk, including the ORNL DAAC, is the Earth State Cloud evolution. The goal of this effort is to further improve the accessibility and usability of NASA Earth science data. And through this effort, we are migrating our data and services from our on-premise infrastructure to the Earth State Cloud hosted by Amazon Web Services, AWS. And a driver of this Earth State Cloud evolution is the need to efficiently handle archival and use of dramatically increasing Earth observation data. For example, with missions like SWOT and NASA US, this archive is expected to increase by multiple folds to over 250 petabytes. So there are many benefits for both DACs and also users with this evolution. And I will briefly explain on the next slide. And here's a link that you can click to check some background information and context for this new paradigm being conducted by NASA. So next slide, please. So this slide explains the big picture, what the future will look like. And the slide is borrowed from Alexei Shklomonov, an ESDIS NASA ESDIS project scientist. And diagram on the top left corner shows where we are today. Data from different DACs, there are 12 of them as Matt introduced at the beginning of the presentation. The data from different DACs are very much isolated, and connection between services hosted by different DACs is also kind of difficult. And users have to interact with different DACs and different tools and services if they need data from multiple DACs. For example, users may need to use ORNL DAAC subset and transformation tools and services to access data hosted at the ORNL DAAC. And if they need to access data from another DAAC, like National Snow and Ice Data Center, they will need to use different tools and services that are hosted at NSIDC. And similarly, they need to use tools offered by Justice, because that's the Goddard DAAC. So it's kind of complicated, and users have to deal with different tools and services and deal with different DACs. But with data and services migrated into the Earth Data Cloud, as illustrated on the diagram shown at the top right corner of the slide, data are now sitting next to each other. Tools and services from different DACs can transform into so-called enterprise tools and services. And those tools and services can work on more USDS data. They don't necessarily only work on data from one DAC. They can access data from other DACs because data are now co-located together in the same location in AWS. And all NASA Earth science data will still be free and open to the public, and that policy will not change. And existing data services, including direct download, will continue to work without disruption. I know that direct download is very popular for especially ORNL DAAC data users because we host typically smaller data sets compared with other NASA DACs. users doing analysis off the cloud, and they can still maintain their kernel flow, and they can do the same thing without any change. But new opportunities arise for users who want to do analysis within the cloud. As you can see on the top right corner, the diagram. So if users want to move into AWS cloud to do analysis there, they have direct access to data located within AWS cloud, and they don't have to download data to their local computer or server at all. So that's a huge benefit. Next slide, please. So what's the status of the Earth Cloud migration? So the ORNL DAAC started the migration effort back in 2021. And so far, we have migrated about 87% of our data by volume. At this point, data are available from both our on-premise servers as well as in Earth Cloud. So we are keeping two copies, identical copies right now, one on-prem, the other in Earth Cloud. And we expect ORNL DAAC data and services to be fully available in Earth Cloud by 2025. DAAC data, of course, are on our priority list of Earth Cloud migration. All finalized DAAC data are available in Earth Cloud. But preprint datasets, which are provisional, as mentioned by Matt previously, we do not migrate preprint datasets to the Earth Cloud as they tend to change before being finalized. So one thing I want to point out is for all DAAC data in Earth Cloud, S3 direct access is available in AWS US West 2 region. And this means if you are an AWS user and want to do analysis in the AWS US West 2 region, you have free direct access to all DAAC data and, of course, many other US S3 data buckets. So you can do analysis and pull data directly from those S3 buckets without needing to download data. And the screenshot here below shows the Earth Search client where you can find the S3 bucket URL for DeltaX average NG-derived water quality dataset. So this is really an advanced feature for users who really want to do analysis in the cloud. And next slide, please. So to fully take advantage of the benefits offered by a cloud computing environment, we have to do additional work beyond just copying data from on-prem to the cloud. In many cases, data needs to be converted into cloud-optimized formats, like cloud-optimized GeoTIFF, COG format, optimized NetSPF format, and ZAR is a new format that's specially created for the cloud environment. So quite a few options so that your data analysis in the cloud can be more efficient, because if you simply copy data from, especially some legacy and old data from on-prem to the cloud, you won't be able to do analysis. Even you do the analysis in the cloud, you won't be able to do that efficiently. You are not using the full advantage of a cloud computing environment. So there has to be some structural change regarding the data. And the ORNL DAAC is very proactively on identifying the different optimal structure and optimal formats for different types of data. And there's no single silver bullet, and we have to find the optimal option for different types of data. So that's a challenge. And the other aspect, another aspect is to leverage enterprise tools and services to support on-the-fly data visualization, subsetting, transformation as much as possible. And those services include OpenDepth service, Harmony service, enterprise ArcGIS server, for the NASA Earth Science Data System. And this will help users who perform data analysis both off the cloud and within the cloud. And the screenshot below here on the slide show an experimental use case that we recently developed using the OpenDAAC service from the Earthstate Cloud testing environment to compare DataX Institute total suspended solids TSS measurements with the average NG-derived TSS estimates. And in this experiment, there's no need to pre-download data files, and only data values from average NG pixels that cover the institute measurement points would be retrieved from the OpenDAAC service on the fly directly from your own Python programming environment. So that's really an advantage. And we hope to be able to release this Jupyter Notebook as a tutorial once we have this production environment OpenDAAC service working. And we expect to be able to do that in the next few months, so really soon. So these are a couple of slides, hopefully to give you an overview and high-level introduction to the Earthstate Cloud and how the ORNL DAAC is working toward that direction. Matt, back to you.
Thank you, Yaxing. Just wanted to point you towards, we have learning resources. Some of those resources are helpful for ORNL DAAC datasets. If it is, there are links at the bottom of the landing pages for the individual datasets, and then some other links here for questions and help. And that's it.